Greetings, my statistics friends. This video is for Chapter 6, Part 2 of your homework. And I'm going to go through 4 questions here. Much of the rest of the questions that I don't cover are very similar to these types of questions. So hopefully we can get a picture of what we need to do. So the first question I'm going to look at is question number 2. So it says assume that x has a normal distribution with a specified mean and standard deviation for the indicated probability. Round your answer to 4 decimal places. So this is the probability that a value x lies in between 7 and 9, including 7 and 9, with a mean of 5.7 and a standard deviation of 1.7. Now this mean is mu, right? So this is the average of the entire population, and the sigma is the standard deviation of the entire population. So we're told it's a normal distribution, so we're going to work off a normal distribution. So I'm going to use my calculator. So this is for a TI-84, and it will be the same exact idea for a TI-83. So what I need to do is I'm talking about a distribution, so I do second and then vars to get to the distribution menu. And the first 2 things listed are normal PDF and normal CDF. Well, since we're talking about many values between those 2 points, we're going to use CDF. So I scroll down to the second one and hit enter. So when I look at my problem, it's between 7 and 9. So my lower is 7 and my upper is 9. So my lower is 7 and my upper is 9. And then my mu is 5.7. So 5.7. And my standard deviation is 1.7. So I type in 1.7 for sigma. And then you go down to paste. For those of you using a TI-83, when you select second distribution, so you get second vars to the distribution and do normal CDF, you will not see this window. In your window, it'll just show up like with just saying normal CDF and then a blinker. So you type in 7, then comma. So the comma is right above the 7, that's a comma. And then 9, comma, so lower, upper. And then the mu, which is 5.7, and comma, and standard deviation is 1.7. Then close the parentheses, and then hit enter. So the answer is 1961.1961 to 4 decimal places. So 1961.1961. And I'm going to submit my answer for practice. And it tells me it's correct. Now be careful when you're watching this video, your numbers might be slightly different than mine. Don't just copy my numbers. Make sure you use your numbers. Okay, the second one I want to do is number 7. So I'm going to go to question number 7. So number 7, there is this pigment that's in the blood. And it says that X is a random variable that represents the number of milligrams of this pigment per deciliter of blood. In healthy circles, X is approximately normal distributed with a mean of 41 and a standard deviation of 9. Find the following. So X is less than 60. That's the first one. So when I do on my calculator, I'm going to do the second distribution, so vars to distribution, and then I want the normal CDF. And then the lower is negative infinity. That's what the lower is. X is less than 60. So the lower is negative infinity. Well, there is no negative infinity in our calculator. So what we have to do is enter in a number that's really, really, really big on the negative side. So not negative infinity, but negative, let's say, 100,000. That's big enough to the negative. That's not negative infinity, but as far as our calculator calculation goes, that's negative infinity enough. And then the upper is 60 because it's less than 60. So less than 60. And then our mean was a 41. And our standard deviation is 9. So then I paste that number and hit enter. Once again, if you have a TI-83, you'll have to put in the commas in each of the numbers, but the format will exactly be the same. So negative, or 9826. So 0.9826. So x is greater than 16. So x is greater than 16. All right, well, how do we do that? Well, the same idea. This time I'm going to do it like I was doing it with the TI-83. And you'll put in the norm CDF with a blinker. So x is greater than 16. So the lowest number is 16. And then comma. And the highest number is positive infinity. Well, positive infinity doesn't exist in the calculator, but I'm just going to put in positive 100,000. That's not infinity, but that's pretty close as far as the calculator is concerned. So then my mean was 60, and my standard deviation, the mean was 41, the standard deviation was 9. So let me make sure I get that right. Mean is 41, and the standard deviation is 9. Then I hit enter, and it tells me 0.9973 if I round to 4 decimal places. 9973 if I round to 4 decimal places. So 0.9973. And it's asked me the next one is x is exactly between 16 and 60. So I'm going to do this time, I'm just going to go up the distribution again. So the lower is 16, the upper is 60, and then mu is 41, standard deviation is paste. And so I get 0.9798. So to 4 decimal places, that'd be 0.9799. So 0.9799. Okay. And then this is x is more than 60. And this may indicate an infection, anemia, or the types of illness. So x is more than 60. So back in my calculator, x is more than 60. So I'm going to do 60 as the lowest. And go to really big number, and then I put in the comma. Again, you could do this with your menu if you wanted to. And paste 41 and 9. That's the idea. And I hit enter. And I get 0.0174 if I round to 4 decimal places. 0.0174. So 0.0174. Okay, and then I'm going to submit my answers and cross my fingers that I did them all right. And it looks like they are all set to go. So that was number 7. Let's look at number 12 from our homework. So number 12 now is saying that suppose x has a distribution with a mu of 34 and sigma of 5. And question A and B, I'll let you carefully read those and answer those questions on your own. Well, one thing that we have to be careful of here is we are not assuming right away that this is a normal distribution. See, it doesn't say anything about this being a normal distribution. So we are sort of being asked questions about things with a normal distribution. The other thing to notice is when we're talking about x, there's this bar over top of x. So that is, well, that's the sample mean, right? So this mu is the mu is the population mean, but the x bar is the sample mean, so we have to be careful about this x bar. And so when I look down here at the probability between 30 x bar and 35, when we looked at problems before, there was just an x there, not an x bar. So this x bar situation, we have to be careful. This sigma sub x is equal to the sigma standard deviation divided by the square root of n, the number of samples. So in this particular case, with the problem that we're looking at, this is x bar. So part B, it says if the original x distribution is normal, so here it does say it's normal, not the same as up above, but here it's saying if the original distribution is normal, can we say anything about the x bar distribution of a random sample size of 16? So our n is equal to 16. So our sigma is 5, so we in our calculator have to compute. So we have to do 5 divided by the square root of 16, which of course is the same as 5 divided by 4. So our sigma sub x bar is 1.25. All the other steps are the same, it's just we have to make sure that we're using this value for our sigma. So I do the second, and then distribution. I go down to the normal CDF. And then I look at my problem here, so I have sigma that I found, but we're looking from 30 to 35. So my lower is 30, my upper is 35, and then my mean is 34. And my standard deviation, again, if I put in a 5 for standard deviation, that would be incorrect. So if I put in this 5 for standard deviation, that would be incorrect. What I need to do is put in 5 divided by the square root of n, which is 16. That's the correct standard deviation. So when I hit paste and then enter my answer, I get this 0.787. 0.7875 if I do 4 decimal places. So this is 0.7875. Again, I'll leave the other 2 questions for you to answer, and I'm just going to answer this last one and cross my fingers. And sure enough, this one's correct. The other 2 are wrong because I didn't answer those yet, but that's correct. So remember, when you're dealing with this x bar, there is this formula that we need to use, right? This sigma sub x bar is equal to our sigma divided by the square root of the number of samples. So be careful with those questions. All right, and then finally, let's look at number 13 from that same chapter 6 homework. So 16 says, suppose the heights of 18-year-old men are approximately normal distributed, with a mean of 69 inches and a standard deviation of 4 inches. What is the probability that an 18-year-old man selected at random is between 68 and 70? So once again, I'm going to go to my TI calculator, and I'm going to choose, so distribution, and my lower is 68, and my upper is 70, 68 and 70. And my mu was 69, mean 69, so 69. And my standard deviation is 4, so I put in 4. And I paste that, and hit enter, and I get 1974, 0.1974. So 1974, 0.1974. And then it says if a random sample of 30 18-year-old men is selected, what is the probability that the mean height x bar is between 68 and 70? So once again, I have this mean height x bar, right? And so I have to use my sigma sub x bar formula. So I take my population standard deviation and divide it by my sample square root of n, the square root of the sample. So I can do that on my calculator. There's 30 selected, and you had 4 standard deviation. So in the same idea as before, I select everything. My lower is 68, my upper is 70, my mean is 69, or I have 4 divided by the square root of 30. And I'm going to paste that. So let me make sure I have the right question here. So the randomly 30, the height is 68 and 70, and the standard deviation was 4. So double check all those numbers. So between 68 and 70, the standard or the mean for the population was 69, and the height standard deviation for this x bar is 4 divided by the number of samples, which is 30. The square root of the number of samples, which is 30. Take the square root. And so I get 0.8291 if I do 4 decimal places. 8291. So 0.8291. And I hit submit answer, and both of those are correct. Now be careful, once again, the numbers that you're given might be different in your problem than in my problem. So double check that these red numbers and put in the appropriate red numbers for your specific problem. Okay, I hope this helps. Let me know if you have any questions.